Hi, I'm Chad. I'm an architect at Palantir. Today we've got Christopher who leads some of our manufacturing work. Thanks for joining me.
Thank you, Chad.
So I know we were going to talk about a lot of different stuff today. One of them being BOMs or bill of materials, pretty central to manufacturing and kind of the trade compliance and how do I make sure I'm following all the rules and regulations with trade across the globe, especially as things are rapidly changing right now. How do we manage through that? So maybe you can talk a little bit about what you're doing in that space.
So a lot of when you think about bills of materials or BOMs and how you frame that, we're really focused on taking actually what goes into the three sort of like silos of the business. So in engineering data, you have all of your bills of materials. You may have in that PLM system drawings or other information that can tell you what you're actually building. But then you often like cross-reference that with another system, such as an ERP. This is where you're actually seeing what's going into the products, what's my customer orders. That then in the trade compliance world also kind of like starts to look at what are the HTS codes and how do they apply to those products. So typically those teams are super siloed. So when you try to do different use cases, you're not necessarily getting the benefits. But via the AIP platform and using the ontology, we're bridging the gaps in those worlds. And that's what's leading us to a lot of different workflows.
Very cool. So yeah, bringing the data together between the kind of the contextual engineering specs and components that are in a lot of different places and the actual context of transactions and real world, combining that to understand like where is their opportunity. So it's very cool. So I'd love to just actually see what you're talking about here because I think it makes it more real. When we talk about BOM, it's a very kind of opaque idea, but why don't we just take a look?
Awesome. So if we look at the screen over here, this is Onyx, which is our notional medical manufacturer and distributor. So they have some different bills of materials of some assemblies that they're building. They build different syringes, which might be available, and they also build more complex products such as T99 ventilators. When we actually go into this ventilator, we can see here via the ontology that we pulled up all the subcomponents that are coming in. And through that combination of ERP data, country of origin data from trade compliance and engineering data, we can actually come here and see, okay, what are the annual volumes on these components? Which countries are they coming from? What's their spend? And so all this together is because we have the ontology that's bridging the gaps between these systems, so we can have one view of all this data. We can also actually look more on like a hierarchical level of like what's actually happening. So here we took that ventilator assembly and we can take the top level components. We can see like what are the mid assemblies and then what's happening at the bottom. And so again, where that ontology really comes into play is if we zoom in on a specific component and we kind of like look around, we can see all the different objects which might be related to that in the ontology. So a BOM component is going to have its parents. It's going to have any recommendations on what might be the materials. You're going to have some drawings and other metadata, or maybe even the supplier. So if we look at something such as a drawing, we then start to bring that out into our view. And you can imagine that we're going across many different systems, which are typically siloed.
Yeah, that's neat. So really the ontology is mapping out the, not just like, here's what in a BOM, but actually the hierarchy, how they fit together, the materials, suppliers, everything. It's like, it's the data, the logic, the action that makes up how I actually produce a product.
Exactly. And while this looks super simple, a lot of companies have multiple PLM systems, which is where the engineering data comes from, maybe even multiple ERPs, because perhaps they like grew by acquisition. They might have different types of components that way, and just bridging that is very complex for an organization.
Right. And some of it's very unstructured data too, because we get into the engineering side. Sometimes it's the drawings of it, of an actual subcomponent and the materials, and like it's not always nicely in rows and columns. So sometimes this is very unstructured, or like mixed with very structured data from like ERPs, and that's where I think really a lot of the complexity comes in is bringing all of that unstructured and structured data to get the real view of what's going on.
Exactly. And then typically where customers like get started is they're attempting to go into these drawings and like writing down different elements, and it's super complex for them.
Yes.
So looking into like some of these bills of materials, this like actually then starts to bring a lot of workflows to the forefront from a Foundry and AIP perspective. So you might be using these to do something for, let's say, obsolescence management throughout your bills of materials. So let's say you have a company and these guys are switching in their ventilator assembly, they're switching the PCB supplier from one company to another. So if you actually think about that, you need to be able to say, okay, from an engineering perspective, I validated this and I'm going to swap my PCBs. But then when I have different plants, it's like, are those plants actually on that revision of the BOM right now in their ERP system? And then when's the right point to do a cutover, right? Because if, let's say, you decide to cut over the product and start using the other one, the other elements that are left over might need to be scrapped because it's no longer in your, as per like your customer specifications, right? So that's one point where you can actually capture a lot of value from this type of workflow.
Yeah, especially in the manufacturing space. Like I always love to see customers starting at the BOM because you can get to cost of goods sold, engineering standards, engineering changeover, inventory levels, procurement. Like it really is the center of the business that is so powerful in unlocking use cases like this.
Exactly. Even sales, when you think about it, right?
Yep.
Because when you're quoting a new project, what did it cost before? What was the impact? How do I try to pass that along, right?
Exactly.
So what we're going to look at now is actually how we can use this in a different realm, which is more so around trade compliance. So there's been a lot of different changing regulations towards trade lately. We have tariffs that are coming in for different reasons, such as steel and aluminum tariffs, AIPA, et cetera. And so we really want to see how can we use this data in the platform to make sure we're compliant. And then through compliance, we can actually reduce our exposure to the tariffs themselves.
Yeah. So what you're saying really is it's not only just that like, hey, these things are changing, but the BOMs can be so complex and sub-assemblies and, how much aluminum does that PCB board have on it or whatever those things are, that it's not that like I'm trying to skirt anything. It's actually coming back to like, how do I make sure I'm compliant and not overpaying, I'm not underpaying, that I'm doing the right thing, I think is really what this comes back to.
Exactly. It's completely about doing the right thing. Because if you actually see how some of these HTS codes are structured, which flag for these, you do have material-specific ones that, yes, this component is made out of steel or it's made out of aluminum. You then also have functional ones. So this is a propeller blade, and a propeller blade is going to flag potentially for a steel tariff, right? But if you're an engineering company and you use different types of materials, et cetera, maybe your propeller blades are made out of plastic. And so the only way you're going to know that is being able to actually go through here to either make sure that you're being assessed on the correct content of steel and aluminum in that item.
Yeah. Okay. That adds another layer of complexity. That cube of trying to figure out like, what am I supposed to, do for this compliance is very complex.
Exactly, right?
Yeah.
And then what you're typically going to see is that customers don't even know where to start. So maybe they have tens of thousands of parts in their like sub-assemblies and components in their part catalog. And maybe they want to start on like, okay, maybe this was the one I imported last month, but that's not necessarily forward looking either, right? So that's where that ERP data is really important, because you can then start to get this intersection of what are the parts that I'm going to be importing the most of based off of my forecasts, et cetera, in the next few months. And then how do I then go through the bills of materials of those and prioritize which ones do we need to update our documentation to make sure that we're compliant and reduce our overall exposure.
Awesome. Yeah. So let's see how we do that.
All right, perfect. So if we look at the screen, imagining I am a trade compliance manager in the Sterling Heights department. I'm looking through here at some different proposals that have come up from the AIP system, and they're making different recommendations to ensure that I have the optimal trade compliance amongst my components. So there could be a recommendation that's coming through because I historically put all of my RFQs into the AIP system, and it realizes that I'm getting hit with a tariff on a component that was actually cheaper from a vendor in the United States who originally bid on the project. So that's a type of recommendation saying, hey, maybe we should go look at that vendor again and see if they could take over the volumes. But there's some other aspects of this as well. One of them is for USMCA certificates. So here we can see a different part number that's being flagged saying that we had a USMCA certificate in 2023, we had one in 2024, and we should reach out to get the one for 2025 to ensure compliance. These are yearly renewals, so you really need to be on top of that in order to capture all the value. The other more kind of like interesting one is that we see some flags for some components that potentially have no steel or aluminum content in them or partials. And so because this is now being flagged by the system, we're going to look a little bit further into what we can do to assess this. So moving to the next screen, we have now my action queue where the AI has queued up different actions for me to look at. I'm going to focus on specifically the Section 232 content analysis. And I can see I have two potential assembly parts that I'm bringing in that are being hit with steel and aluminum tariffs. And the system is actually recommending to me that they may not actually have steel and aluminum or maybe partial. So how that kind of like works is we go through these different steps. So there's a component flag for section 232 from the live broker data. We then have different components that are analyzed in that bill of materials, and then the entire assembly is being analyzed by AIP. So we see here this enclosure, it's an enclosure that's coming in from Mexico. The annual volume is 100,000 units. We're spending 410,000, all from the ERP data, we know this. And then we have a potential tariff impact of $100,000 that's coming through. But when we actually look here, AIP has flagged this as having no steel and no aluminum content. So that gives us the ability to start to then go to the subcomponents in this bill of materials. We have some parts drawing from our engineering data, and we can start to see here, okay, this is a plastic feet standoff, different card slot brackets. If we want to, we can pull up the spec sheet as well to see this is actually a text spec sheet for a polymer, so that makes sense. And then we have the ability to accept or reject these recommendations. Typically, when we look into something like this with trade compliance, you do want to have a human in the loop who's making this final decision right before you file these. So the importance here is that AI is being used to prioritize these and based off of impact, kind of like the 80-20 rule of saying 20% of the parts are going to have most impact. And then you have your trade compliance team actually do the final assessment and collect any documentation they need in the platform to actually go take action on these.
Yeah, because the inverse of this, when you don't have this, is you're opening up specs, going through PLMs, emails, spreadsheets, trying to find all of the complex subassemblies versus here's the one that we think has the most impact and all the information about it. We think this is the right call, yes or no. I think that's like a distinct difference of the before and after, right?
Oh, exactly. You could be spending like one day just trying to analyze these parts if you're just looking at the drawings and trying to move through that on your own.
So, I mean, this is cool. Like, this is a notional example. This makes a lot of sense from like, it's plastic. I have aluminum tariffs, and I want to go through. And as your BOMs get very many levels deep and they're super complex with thousands of items, it's hard to track. Like, how are customers doing this? I guess this is inspired from customers?
Yeah. So a lot of customers are actually doing very similar work to this. And it's funny, where they typically start is I'm just going to pull up all my PLM systems and go into spreadsheets and just attempt to do this. And you see it taking like days to even just process one part, right?
Wow. Yeah, and that's got to be hard because if it takes you a day, as things are constantly changing and moving, knowing that kind of impact can be very hard. So every time something changes, you have to kind of reassess those impacts. And I think that's really the power of AIP here.
Exactly. And even just in the ontology of storing these parts, because you could be assessing the same components and the same assemblies over and over and over, and you wouldn't know that if you're just working in spreadsheets.
Oh, wow. Oh, yeah, because the subassembly that goes to multiple different parts, you could be reassessing all of those as you go down the tree. It could be very difficult. Interesting.
Exactly.
Yeah. So from an impact standpoint, like, you know, doing this at scale, it's not only just the human component of like, I'm not spending a day doing each one, but it's I'm in compliance, not getting fined. And two, I'm saving money because I'm in compliance. I'm not overpaying. So I think there's like 3 big wins there, not only beyond just the kind of the human piece of it.
Exactly, right? It's being in compliance so that you don't have to pay these anymore. And then also actually going back and saying, now that you have all your documentation together in one place, can I go back and recover these, right?
Yeah.
So there's actually potential on both sides.
Very cool.
If we take a look further, actually, just wanted to zoom into a specific example here. So more complex than a component that may not actually have steel and aluminum in it, but was flagged, is when you have partial steel and aluminum content. So in this case, it's another type of enclosure that's coming in from Mexico. And it has a lower tariff impact, which is why it's kind of like below the other one on the list. It's flagging as no aluminum content, but it's flagging as it does have steel content. And the reasoning from the model is that there are these 3 specific components in it that are explicitly described as steel, right? So when we go through here, we actually see, there's a lot of different plastic housings. There might be a washer that is made out of nylon, but there's a steel screw. We may have some different information that goes through, such as like a drawing where, hey, this actually, if we zoom in here in this little block, we can see that it's stainless steel. And so the key is that we need to be able to process through all of these very quickly and efficiently to even know this in the first place, so we can bring this up to our teams to accept what we're looking at. And that's where AIP logic is really coming into play. So that way we can have an AI agent, which is doing a lot of this pre-processing to make sure that our trade compliance teams are just focusing on the real impactful work of actually putting the package together and closing these out.
Very cool. So you said AIP logic. What is that?
So AIP logic is one of the tools in the AIP platform that allows us to orchestrate LLMs to be able to work throughout the ontology. So I'm actually going to pull one of those up right now. So this is the tool we're looking at. And this is where we're starting to design how we're going to have our AI agent, which is moving through these bills of materials. I'm going to open up a test case for us so that way we can see exactly like what we're looking at. And so I'm going to run this on one of the components as an example, and then walk you through exactly what we're seeing. So the first thing that we do is we started our bill of material component in our ontology, and we use the linkage between that and the part drawing to go see, do I have any part drawings? Do I have any other documentation that might be in my system that's linked to this component? After I do that as an assessment, I say, actually, I do have a drawing. I'm able to pull one model ahead to actually take a look at this and to see what it thinks. So in this case, we have a prompt, which is going to our model, and it's saying you're an expert in interpreting part specifications, sheets, and mechanical drawings. So given this image of it, can you extract and list out all the materials for this part and pay special attention to steel and aluminum? And you could easily modify this to include copper, et cetera, in the future. And so what's happening if we actually track this through in this panel here, if we open up that step that's equivalent, we can see, okay, here's where the model went to that drawing we just looked at earlier, and it's pulling out stainless steel.
Yeah. I think an important point you're bringing up here, because like we're now talking about LLMs reasoning, doing retrieval augmented generation across the ontology, but also multimodal. Like we store multimodal data in the ontology to represent how this is really happening. But that becomes very important on the agentic side, is now these agents are accessing via either vector store in the ontology for semantic search to find things, or they're going and looking at the images that are stored as part of this, so that one semantic object can have this rich representation across all of those different media types. And like, this is a great example why that's important when you're doing agentic flows, is now it can also reason across the different medias that we have too.
Exactly.
Yep.
And what's even more interesting about that too is that it leads to even more use cases. So here's something we're looking at materials for trade compliance, but a lot of customers actually do workflows where they do material harmonization, where they're kind of looking between all of my drawings in my engineering database to say, could I be buying the same part under different part numbers in different areas, right? And so that's like using the next use case that you build on top of it to get even more value.
Yeah, and I think that's the power of the ontology, is really the high level of reuse, the malleability to your use cases. But, you know, injecting that extra layer of things on top of it, it's like, no, I already have the ontology 90% there. I just need some more objects. Let me go build that. Think about it differently. And I think that's where also then these agentic workflows come in as well, as now I can start to string those together across business processes to automate more and more of a business.
Exactly. And some businesses may say, actually, I don't exactly have the drawings readily available, but that's okay too, because that's where you can start to use more of the reasoning parts. So we actually take this information and give it to a second model a little bit later. And if there's any drawing information available, we tell it to take that into account. But it can also use things such as part descriptions, some understanding if you give it maybe the HTS description, so that it can kind of like do its best guess in the absence of some of that other data to at least help you do that prioritization workflow. So in this case, we have a second model, which is now assessing based off of the description of the part number, and anything it was able to get out the drawing. Does it contain steel or aluminum? Yes, no, right? And then at that point, that's what's then given back to this action in the ontology. And then we're able to actually write this back against the specific component in that bill of materials, which is what was showing up in our application.
Yeah. So the other thing I noticed here is you're using multiple different models in one agentic flow too. So I saw Gemini 2 Flash for the kind of image extraction piece. And then now I've got GPT-4o for reasoning pieces. I think that's pretty cool from a standpoint as I can mix and match models for the right size, the right use case, even in one agent.
Exactly.
Yeah. And I think that's important. You're also showing the test components and evaluation, like how do I evaluate this at scale? But the last part I'm going to call out here is like, these are actions defined in the ontologies. The ontology is the guardrails for getting access to data, the logic of the different components. but also the actions, because I want the agent to take an action. And sometimes the agent says, hey, person, you need to review this. Other times it's I write back to your SAP system, your PLM, to make this real. And so I think that's the other piece here that's important, is we can drive those actions on guardrails through the right security primitives back to source systems to make it like, scalable across hundreds or thousands of these different use cases very quickly.
Now let's go back to the application and see the next step so that we can close this out. So going back into the application, we can look at where our component is, and we can see we might need to collect some supplier information now, because if it's partial steel and aluminum, we may not have that in our data. And so we want to go to that component specific supplier to figure that out. So if we click the Take Action button, that's actually going to open up another window for us. And here we can see that there's a proposed supplier who's related to this component via the ontology. And then we're going to ask a model to actually start to generate that out for us so that we can reach out to these suppliers. It's put together this information. It's now going to request the steel content, the weight, the country of pour or smelt in the case of aluminum, etc. So that way we can get all this information together and we can send this out as an email to the supplier. In this case, we actually already got a response. So the system can actually now use another agent, which is actually going to read through this and check, did we get the right information back? If we didn't, we can request further clarifications. But the other thing that we can do is accept that supplier response. That's going to show us that we parsed out the values that they've sent back to us. And then when we click submit, we can commit that to the ontology and then now put together the entire package. So we have all our supplier communications, we have all our drawings available, we have the bill of materials for the parts, everything's logged in and auditable in terms of a package. And then we can see that while originally we were getting tariffed on a $3.60 unit price of a component, we've actually reduced that because only $2 of the component's constituent materials is actually steel and aluminum. So when you're actually now compliant with the tariff, it's actually reduced it by $88,000 for the year.
Oh, wow. Okay. So that's cool that now I'm simulating out, finding solutions, simulating out the impact, and then can make it real, and understand what that impact is before I make it, all with human and AI working together. That's pretty cool.
Exactly. Right. And it's, if you just think about the scale of the different systems here, communicating to brokers, communicating to suppliers, super, super difficult unless you have a platform like AIP.
Yeah. And it's it's easy to understand and one off. But okay, now go do this for 10,000. Right. That's when you really need a system like this to prioritize, facilitate, bring all the data together and everything like that. That's cool also because now I can track the impact and success of these things. So from an ROI perspective, for people to take on projects like this, having a hard ROI of the money saved by being in compliance, that's pretty powerful.
Exactly. And it may not even be in terms of your filings. Perhaps you have customers who have more control over their supply chain, and they might actually want to know, when you're passing on potential tariff costs onto them, how are you accurately passing those costs onto them, right?
Oh, wow. Okay. So that facilitates the conversation when a tariff has forced us to increase the price to our customers to be able to say, actually, it's because of these components. Here's what that cost differential is, to be fully transparent when you have to make those changes.
Exactly. And let's say if you're making a subassembly for a bigger equipment manufacturer, you have to make sure that you're properly allocating which tariff goes to which manufacturer. Otherwise, one may say, how come I'm paying the tariff that is on components going to the other guy, right?
Yep. Okay. That makes a lot of sense. Okay, cool. So that was awesome to see kind of in action, the flow of how things are integrated. And I love always that when we talk about AIP, it's not AI in your face. It's actually in the background automating really that autonomous enterprise. But speaking of that, what are you seeing across customers and what are they looking for in the space? Why is this moving so quickly?
Good question. So because the regulations are changing so quickly, you have to be very agile in order to adapt your system so that you can respond to that. So for example, some of the other tariffs, if you had a USMCA certification, you would actually be exempt from them. But the problem is a lot of companies don't necessarily manage their USMCA certifications correctly. They expire every year. So you really need to have a helper, in this case an AI agent, which can actually run through those and say, hey, like you're going to be importing a lot of this part number and you had a cert last year, but you don't have one now. So let's go collect it. Another case is also in terms of just if you're creating new components because you're like having revised products, you may not necessarily be importing the same products this year that you did last year, right? And so if you then go off of historical lists, you're not actually going to be seeing what's ahead of you and prioritizing yourself correctly.
Yeah. Yeah. And all of this is moving so quickly. Like, how long does it take customers to get spun up on something like this?
So a workflow like this typically takes a couple days to get the first version set up, and then they can be off and running within about a week and a half. And that's also really important because while going forward, you want to be compliant so you can have correct filings, you do have an opportunity to actually go back and correct your filings, but there's sort of like a cliff that it approaches, at which point you can't actually correct anymore. So the faster you get going, the better that you can make sure that you're being correctly charged for your tariffs.
Wow. Okay. So being able to set this up in a few days to be able to start to recover these things, get in compliance, it's never too late to get started, I guess. And so it's a pretty good story across a lot of what we do at Palantir, but specifically in this where, hey, things are just happening. I need to adjust to my business. There's nothing else I can do besides move quicker and be compliant and agile with what's happening. And so I think that's a pretty powerful story. What's the bigger vision now that I have this BOM and I've connected all these systems? Like, what other things can I do with that?
Well, that's a good question, Chad, because it's really interesting that once you've gone into your engineering systems, such as your PLMs and your ERPs, put that together, this is a really good starting point to be able to do other use cases. So for example, back to the obsolescence management, that's very valuable for how do you make sure you're not sitting on different inventories, doing the material harmonization where you're analyzing across your spend, potentially am I buying the same thing in multiple places? And then even when we think about when we're doing RFQs for future procurement needs, maybe now you can properly assess a vendor in the United States to be awarded business in the future because it's actually going to be cheaper.
Yes, it's that balance and way off. I think similar like cost of goods sold and understanding really there all the way to sales and supply chain. I think the BOM is really the center of a manufacturing company. So it's that bleed off to other use cases that's so powerful.
Even think production scheduling, right? The only way you're going to know if you don't have components to actually build that product on the line is if you can properly traverse the bill of materials and go check your inventories.
Yes. So definitely it's cool. It's a cool motivator to start with the BOM. I think that leads to a lot of other use cases, but it's really about how do we help people move with what's important in their business right now, and it's ever changing. So thanks a lot, Christopher, for showing me this today. It's pretty insightful to see this work and how do we do these things, because on her surface, it doesn't seem that difficult, but man, in the details and at scale, this is very, very hard.
Exactly. Thank you, Chad.